Okay, so today we are going to be going over how to view and analyze our total scattering patterns using the ADDIE software in this video. The first thing we need to do is to access the analysis cluster. So if you haven't done this already, we have a video that explains how to. But today I'm going to use the ThinLink client to connect. So now we're connected to the analysis cluster, and the first thing we need to do is to launch the ADDIE software. So we need to go to the terminal, launch that, and from there we then type in ADDIE and hit enter. And this will begin to start up and load the GUI. So now we have the GUI loaded. We maximize that. You see we have different tabs here. So we have the post-processing, the brag patterns that we can view, and we have videos for those. And today we're going to be looking at the total scattering patterns, so we're going to go to this Calculate G of R tab. Okay, so from here we can see that we have two of these plotting canvases. On the top we have the S of Q, and then if we perform a Fourier transform of the S of Q, then we get the G of R, or the pair distribution function, or the PDF. So the bottom canvas is for the G of R. So the first thing we need to do is to load in an S of Q pattern. So you go up to the top right and we load in S of Q. So we need to navigate to our data. So we first go to the SNS folder. You have all the instruments here. So we're going to be using Nomad. So we'll go to the Nomad folder. Now we need to locate our IPTS. So today we're going to be using 21285. So if I scroll down, we found it right here. We're going to go into this IPTS. So we have two folders here. We have the shared folder and the Nexus folder. The Nexus folder has these Nexus files that contain our raw neutron event data. And then in the shared is any reduction we've done from these files goes here. So we have these autonom folders where we've done some previous data reduction. We're going to go into one of these that we've been working in already. We're going to scroll down and we're going to locate this S of Q folder directory where the S of Q patterns are located. So if we open this up, we see that we have these files with the run numbers. So these were produced from the auto reduction. So these are patterns for each of the individual runs. If we scroll all the way down, we can see that we also have some that were produced from post-processing in a previous post-processing video for the Si2 glass powder. And here we have one that was for the base Qmax range. And we also have this 20, 30, and 40 for files that were produced from different Qmaxes. So if we scroll back up, first we're just going to pick one of these patterns initially. So we see that when we do that, the data is loaded in and automatically plotted in the S of Q canvas. And also based on the Qmax that's and Qmin in this data set, the Fourier transform is automatically done to produce the G of R for this data as well. So now I'm going to actually load in, or let's clear the S of Q. So we can clear the canvas with a clear S of Q button here. We can also clear the G of R pattern here. And now let's load in, we can actually do multiple data sets. So we can click on one and hold shift and click on another to do a continuous selection, or we can also click on one and hold control and click on another to do two data sets or more at the same time. So we're just going to do these two initially. So if we open these, we see that both are automatically plotted and both are automatically Fourier transformed. So now we're going to actually clear the canvases and delete this data. So we're going to clear the S of Q again, clear the G of R again. Then also you see that these workspaces are located in these workspace trees. So you can right click on them. You can see that you can replot them if you'd like. Similar options for the G of R. You can also right click the top head one and say just delete the data and delete the data. And now let's load back in our post-processed SiO2 glass powder pattern. Great. So now one thing that we can do is we have different options that we can do for the SFQ over here. One thing that we can do is we can zoom into the pattern, previously how we did with the Bragg diffraction. We can zoom back out. You can also zoom in, press the rescale button to fix the scale on this, and then zoom back out. We can select one of the patterns and then change, say, the color to black, and then apply a marker to it as well. We can also go back in and select to not have a marker, and select to also have no marker, apply. We have edit SFQ. So from here you can actually perform shifts and scales on the data, and you actually have slider bars that could do this interactively. And you can select the different patterns that we've already previously loaded from here. You can clear the SFQ that we've already talked about, and then you can save out the SFQ pattern. So now you can also change the SFQ pattern up here to a different form. So you can do SFQ -1, so where 1's been subtracted from it. And you can also do Q SFQ -1 or F of Q in some texts. And this is actually the kernel of the Fourier transform. And then go back to SFQ. So now we can see this is our section that can control the Fourier transform of this pattern. So if we click generate G of R, we'll create a new G of R pattern. We can select different functions. So little G of R, the radial distribution functions. We can select G of R, select this, and we see that there's actually a very small pattern for, you can see very faintly that we have that one right here. Let's actually change this to stars and red. There we go. So we can see the little G of R pattern that we have here. You can zoom that back out. We can input a density that's required for the radial distribution function. We can also do, if we switch back to large G of R or the PDF, we can do a modification function, so a Lorch function. And if we click that, we see that we have the pattern that's generated. And what this does is it helps us reduce the Fourier transform ripples that occur, but it also broadens out our peaks. So this can help you try to identify what are just Fourier transform ripples from the high Q that you have, but also to dampen your peaks. Usually this isn't desirable, so you want to find the Q max that reduces these ripples and still retains these peaks. So we'll turn that off. So you could say that if we wanted to reduce down this Q max to say 25, we want to know, we can also click show min and max to say where is this transform going to be performed in the pattern, and click generate G of R. Now we see we have one where we've maybe slightly reduced the ripples and still kind of somewhat retained the peak shape, especially in this one over here. We can also adjust the R max. So if we zoom back out, we see that we're getting truncated at 20 due to this R max here, but if we put in 50, and then I generate a G of R pattern, now we have our pattern that's going out much past that. So we can click this checkbox and go to the x-axis and say, put in 60 and apply. Cancel. And now you can see that this is how far out we are in now based on this R max value. So and the last thing that we can do, so we have our patterns here, or we have our data sets here in the workspace tree, and we can right click, and one of the useful ones is we can say to IPython. So if we click that, there's actually an IPython widget down here that contains this data set, and it already has the Manted framework already pre-loaded. So we can use Manted to do different operations and manipulations on these data sets. So one thing that we can do is if we want to say scale this S of Q by a given number, one thing that we can do is say subtract by 1. So this will shift it down to the 0 axis first for us. So we can scale there without changing the high Q. We can multiply this by 2 and then add 1 back. So this is on the SiO2 glass powder, and we'll say this is going to be our SiO2 scaled data set. So if we execute that, we see all of a sudden there's a green pattern up here for the SiO2 scaled. We can now select that here as well and generate a GFR for that pattern, which then shows up down here. So we can scale the GFR as well. If you need to see what you're doing down here a little bit better, there's a dock widget, so you can undock this and kind of resize it to a certain point. So you can manipulate the data sets and then redock it as well. You can also, we're working on doing a reverse transform, and then you can also save out these patterns as well. So we can say we need to select one from up here, but we can select one, save GFR to wherever you'd like, and we have different formats. So the PDF GUI, RMC profile, comma separated variable, and then just a XYE column format as well for the GFR. And that concludes looking and viewing and manipulating your total scattering patterns. Thank you very much.